All right. So in today's class, we are going to do binomial expansion, and of 1 plus x to the power of n for values of n that are not positive integers. In your AS level, you have done binomial expansion for the values of n that were positive integers only. Now in P3, we are going to look at the expansion of 1 plus x to the power of n, where n is not a positive integer. Now, if it's not a positive integer, that means that it can either have a negative value, negative integer, or a fractional value, anything, but it's not going to be a positive integer. Acha, so the formula for the expansion. Now, in AS, when you were doing expansion of 1 plus x to the power of n, you were using this formula a to the power of n plus ncr a to the power of n minus r b to the power r. You get this? You remember this?
Yes, I remember.
Now, we are not going to use this over here because that formula was only applicable when n is a positive integer. Now, when n is not a positive integer, we use this formula. So, if the first term is 1, then it is going to be 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n minus 1 times n minus 2 over 3 factorial x cube, and it goes on. Now, in this case, n is a rational value, and this formula is valid for mod of x less than 1. Now, we are going to discuss what does this mean. Do you remember, or were you told that NCR is also n factorial over n minus r factorial? Something
No,
like that.
told that.
Okay, so basically, when take out your calculator, if you can't, NCR was basically used in combination. You would have done that in S1 as well.
Yes, sir.
Okay, just give me a minute. I'll get my calculator as well.
Okay.
Okay, so in AS maths, when you were using NCR, so n had to be an integer value. Like we cannot have n as 2.5 C1. Okay, 2.5 C1 doesn't exist. You are going to get a maths error.
Yeah.
So this form of the expansion was only valid for n being an integer value. Now we are going to do questions in which n is not going to be an integer. So this is another form of the expansion that we are going to look at. The first term will be 1 always. If it is not, then we'll make sure that it comes out to be 1 by taking something common out. And we are going to make the first term as 1 always. Now, over here you have plus x, it could be plus x squared plus x upon 2. Basically, this term indicates the second term. So whenever we have 1 plus x to the power of n key expansion, the expansion is equal to 1, the first term 1, plus n times x plus n times n minus 1 over 2 factorial. I hope you remember 2 factorial किसे कहते हैं? 2 times 1, 3 factorial is 3 times 2 times 1.
Yes.
So, right? Do you remember?
Yeah.
Okay, so the third term is going to be n times n minus 1 over 2 factorial x squared, meaning the second term squared, plus the fourth term is going to be n times n minus 1 times n minus 2 over 3 factorial times the second term cube, and this is going to go on. It is going to continue. So if you remember, when n was a positive integer in P1 maths, then the series was finite. The series was finite, meaning it has to end. For example, if n was 5 and you were asked to expand this 1 plus x to the power of 5, you know that there were 6 terms, right? There were 6 terms,
Yeah.
right?
Yeah.
Now, over here, if when n is not the positive integer, then the series is going to continue. It is going to be an infinite series. So one observation is that the series is going to be infinite. The series, the series is infinite, and this expansion, the expansion is only valid for mod of x less than 1. Now, if you remember, mod of x less than 1 means the second term must be between minus 1 and 1. So, the second term, which is the x, must be between minus 1 and 1. That is what mod of x means. So, if x was a upon 2, let's say, so a upon 2 would be between minus 1 and 1. So, a would be between minus 2 and 2. So, if this expansion is only valid for those values of a where a is between minus 2 and 2. Now, it's going to make more sense when we are going to look at some examples. So the proof of this formula is beyond the course of this syllabus. Okay. So we are not going to go in detail like how is this expansion formula derived. We just need to remember this formula and we need to understand how to apply it. So I'm going to go over some examples. I want you to do this with me. So let's say if you have a series of
Sir, are you speaking right now?
hello, can you hear me now?
Yes, sir. Now I can hear you.
Yeah, sorry, it was disconnected.
Oh,
Let me know when the screen gets visible.
yes, sir, it's visible now.
All right. So if we have to look for 1 plus x to the power of minus 3 key expansion, the first term is going to be 1 plus nx. Now n value is minus 3 and the second term is x plus, okay. Then the third term is going to be n minus 1, which is going to be minus 4 over 2 factorial second term squared, then n minus 1 n minus 2 over 3 factorial the second term cube, and this is going to keep on going further. If I write down one more term, that is going to be n minus 1 n minus 2 n minus 3 over 4 factorial second term to the power of 4, and it is going to keep going. So this is an infinite series. So the question will always ask you, okay, expand this till this particular term or till the coefficient of x to the power of 4. Okay, the only difference between an expansion of n as positive integer n as a not a positive integer is that for the positive integer expansion, if the value of n was a positive integer, then the series is going to be finite. We know that it is going to end. If the value of n is 6, then it will have 7 terms. But when the value of n is not a positive integer, the series is infinite and it is going to keep on going. So if I solve this, I'm going to get minus 3x minus 3 times minus 4 is 12. 12 over 2 factorial is 6. So this is going to be 6x square. Minus 3 times minus 4 is positive 12. 12 times minus 5 is 60. Minus 60 divided by 6 is going to be negative 10. So negative 10x cube, and the last term is going to be 15x to the power of 4. Any questions in this expansion?
No, sir, I got it.
Okay. Now this expansion is only valid if the second term, which is x in this case, is less than 1. So if you are ever asked if for which values of x is this expansion valid, you are going to take the second term, write it in mod sign, and you are going to write less than 1. And then you're going to write down the final step as an inequality that x is greater than minus 1 and less than 1. That is going to be the answer.
No, I don't
So,
understand this part. How do you know that x is less than 1?
do you remember when we were doing modulus inequalities?
Yes, sir.
So, if the solution was in the form of let me show you. I have this over this slide. So when we were doing modulus inequalities over here, so if mod of a was less than equal to b, then I said that a must lie between minus b and b inclusive.
Yes,
So if
sir.
you compare this with mod of x less than 1, so do we agree that x should be between minus 1 and 1?
Yeah, sir, this part I understand, but I don't understand where x was shown to be in the range of these values.
X was shown in the. Mm, can you just rephrase the question?
As in,
Like, I
sir,
don't understand the
how
question maybe.
how do we know what the values of x are?
So basically, it's an algebraic expansion. So we don't know the value of x right now. But
Okay.
what we know is that if we want to expand something like this in this form, this expansion formula is only going to be valid if this condition is met. Now, this means the second term, whatever the value of x is going to be, the second term will have a modulus that is less than 1. So that further indicates that the values of x must lie between minus 1 and 1. Now it's an algebraic expression. Like if x would have been, if x is between minus 1 and 1, and let's say x has a value of 0.5, and you are asked to expand this to, let's say, minus 5. So the value of x is this.
Okay, sir.
Okay, I have told you that this is the value, but over here we are talking about algebraic expansion of this 1 plus x to the power of minus 3. We don't know the, this is not a value that needs to be expanded or needs to be evaluated. This is an expression. This is an algebraic, you can say, expression that needs to be expanded. So 1 plus x, the whole thing power minus 3, is going to be equal to this. Now, to further clarify your understanding, so you know that 1 plus x to the power of minus 3 came out to be equal to this value. It came out equal to this value, right?
Yes.
So if x was equal to 0.02,
Then
can
we would just
I can you just use this expansion by plugging it x over here? Can you just confirm by plugging x over here, whatever the output we get to be equal to what the output if we plug in x as 0.02 over here and solve it through the calculator?
Okay.
So it's going to be roughly the same.
Yeah, so it's the same.
Right? What's the value coming?
0.9423.
0.9423
23.
on both sides.
Yes.
So for few decimal places, the value is exactly the same. So basically, we are using the expansion of this bracket to evaluate this result. Okay.
Okay.
So does that answer your question?
Yes, so it does. And so does it matter how many powers of the x you take, how many values you find on the right hand side? Oh,
No, that's not the case. Like you're comparing it with the expansion of 1 plus x to the power of n, where n was a positive integer in P1 paper. So if n was 6, we were able to guess, okay, now there are going to be 7 terms. But over here, we are not able to guess because it's an infinite series. And
yeah.
infinite series actually means that it is not going to stop.
Okay. So
Okay.
you so you can take as many values as you want.
Now n could be anything, and there would be infinite number of terms. Right now on the screen you can only see 5 terms, but I know it's an infinite series and it is going to have an infinite terms, and where n could be anything.
Yeah.
Only when n is a positive integer, then only the series is going to be a finite series. So the terms are going to be limited. But when you don't have n as a positive integer, you're going to get a infinite series.
Okay. So, but would the values for the answer on the left hand side and the right hand side be the same even if you were to add more values on the right hand, more like terms on the right hand side?
Yeah, so basically, this right hand side is going to be a very good approximation to this answer of the left hand side. So the idea is that as you go on, the next value is going to be very, very, very small. Then the next value is going to be further small. So adding these values would be insignificant, but value तो है. अगर
Yeah.
0.00001 का भी फर्क आ रहा है, you would hardly notice, but the value is still going to be added up because the value of the subsequent values, the values ahead of these terms are going to be further small. You getting my point? Because this value is between -1 and 1. That means 0.99 भी हो सकता था, 0.8. So अगर मैं 0.8 की पावर 50 लूंगा, तो it is going to be roughly 0. Okay, 0.8 की power
Okay.
50 comes out to be 0.0000142. Now 0.942 में इसको ऐड करने पे कुछ इतना सिग्निफिकेंट फर्क तो पता ही नहीं चलेगा आपको.
Yeah.
Okay, so this side is a better, this side is just an approximation. Yeah, this is just an, this is used an approximation. The expansion of this, which is this term, these terms are just an approximation. They are not going to give you the exact result, but will give you the approximate value closer to this, right?
Yeah.
Okay. Now 1 plus x raised to the power of half. Again, the value is a non-positive integer. It's not a positive integer. So it's a fractional value and a positive value. So the first term is going to be 1. The second term is going to be n times x. If you have a formula in front of you written, can you just help me in filling these terms? N times the second term. Then what is going to be the next term?
Um, n times n minus 1 upon
So 1 upon 2 times,
minus half
yes, over 2 factorial, and the
times,
second term squared.
yeah,
Then,
half times minus half times minus 3 upon 2
right,
upon 3
over 3
factorial.
factorial,
Factorial.
second term cube. Yes. Then, following the same drill, n minus 1, n minus 2, n minus 3 over 4 factorial, second term to the power of 4. Now all you need to do is just to simplify. Now partial fractions and binomial series are very easy topics. The only thing you can mess up is with the signs and the calculations. So ये क्वेश्चन जितने इजी होके कर सके ना आप वो करिएगा. Like don't rush in calculating because a single sign error or a single value error could lead up to a wrong calculation.
Okay.
Okay. So I want you to solve this and then you can compare these answers. Okay, I'm also solving it, you can also solve it. And then once you are done, you can compare your answer with mine so that you have a practice about for this.
Yeah, so I'm getting the same answers.
Okay, great. Okay, so the question that we have is expand 1 minus 3x to the power of negative 2 in ascending powers of x up to and including the term in x cube, and state the range of values of x for which the expansion is valid. So we are going to start by expanding this up to and including the term in x cube. Now that's my first term, that's my second term. Okay. So the expansion is going to be 1 plus n. So what's the value of n?
Minus 2.
Minus 2. The second n times the second term, which is minus 3x.
Yeah.
Okay. Plus
Okay.
n times n minus 1 over 2 factorial second term squared plus n minus 1 times n minus 2 over 3 factorial second term cube. That's it. I'm going to stop till here because this term is going to give me x cube term.
Yeah.
So I was asked to expand till here. Now you're going to simplify this and you're going to get 1 plus 6x. 2 and 2 would be cancelled out. 9 times 3, 27 x squared. 27 times 4, 108. So that should be your answer for the expansion. Now, as far as the question says, state the range of values of x for which the expansion is valid. The expansion is valid. What was the second term? The second term is minus 3x. So the expansion is going to be valid for the mod of minus 3x less than 1,
Okay. So
right?
you always write
But
that.
yeah, we always write that. Now, what is the significance about this mod sign on this negative sign?
It'll make it positive.
Yes, it is going to make it positive. So mod of 3x is less than 1. And the range of values of x is going to be 3x greater than negative 1 and less than 1. So x is going to be greater than minus 1 upon 3 and less than 1 upon 3. Okay?
Okay.
You can just copy this down. I'll answer a call and get back to you.
Okay.
Okay. Any questions still here?
No, so I understood this.
All right. Now the next question says find the first four terms in the expansion of 1 plus 2x squared to the power of negative 4 and state the range of values of x for which the expansion is valid. Again, it's the same type of question. So I want you to try out first and then I'm going to help you
Okay,
out.
sounds
Okay?
good. Sir, I've done it.
All right. So n value is -4. So the expansion is going to look like 1 plus 2x squared to the power of -4. So 1 plus n second term n times the second term plus n times n minus 1 over 2 factorial times second term squared plus n times n minus 1 times n minus 2 over 3 factorial second term cube. So these are the first four terms, including 1. So 1 minus 8x squared, then 40x to the power of 4.
Yeah. And 160.
3 factorial is 6. It will cancel out. Minus 20 times 8 is negative 160 x to the power of 6. So these are the first four terms of the expansion.
Yeah.
Now, as far as the second part to the question is concerned, for which values of x is this expansion valid? So for that, I will have to take 2x squared, the second term of mod is less than 1, which means 2x squared is greater than -1 and less than 1. So x squared is greater than -1 over 2, less than 1 over 2. Okay, it's better that we write.
Good.
Hmm. So just a second. So one thing I know is that this was mod, right? Hmm. Now the problem is that if I take square root on both sides, I know that square root of -1 upon 2 doesn't exist.
Yeah.
So I think this is just going to be the answer.
Okay.
Either we can leave our answer like this over here, or we can write x less than 1 upon square root 2. Okay.
Okay.
All right. Find the coefficient of x cube in the expansion of x minus 5 over 1 plus 2x. Okay, so in order to attempt these types of question, we need to look the question in this form. So if you take the denominator that has a power of 1 into the numerator, would you agree that it can be written as x minus 5 times 1 plus 2x to the power of -1?
Yes.
So I can apply expansion series formula on this and then multiply the expansion terms with x plus 5. Would you agree with that?
Yeah.
So that's how you are going to solve this first. The first term is going to be 1 plus n times second term plus n times n minus 1 over 2 factorial, the second term square, plus n times n minus 1 times n minus 2 over 3 factorial, the second term cube. Okay, I'm going to do till cube.
Okay.
1 minus 2x plus 2 and 2 cancel, 4x square minus 8x cube. So these are the first four terms of the expansion
Yes.
of 1 plus 2x to the power of minus 1. Now I do not want the coefficient of x cube of this term, this expression. I want the coefficient of x cube when the expansion of this has been multiplied with x minus 5. So I'm going to multiply x minus 5 in such a way that I just get the x cube coefficient. So this x needs to be multiplied with 4x
Four.
square to get the x cube coefficient, and minus 5 should multiply with minus 8x cube. So x times 4x square minus 5 times minus 8x cube. What does this comes out?
44x cube.
Yeah. So 44x cube. That's correct. So that's your coefficient. Okay?
Okay.
Yeah. If you need time, you can copy this down.
Yes, I have it down now.
Okay. All right. Now it's time to look at the expansion of binomial to look at binomial expansions where we do not have the first term as 1. So in this slide, we are going to learn the binomial expansion of a plus x to the power of n for values of n that are not positive integers. So the only difference is of this a. For example, 2 plus x to the power of minus 3. Now, in these cases where the first term is not 1, you are going to make this first term as 1. And you can only do this by taking 2 common from 2 plus x. So if you take 2 common from 2 plus x and let the other things remain same, you're going to get 1 plus x upon 2. Is that correct?
Yes, sir. Sorry, my mic was muted.
No problem. So are you fine till here? Is the concept clear?
Yeah.
Okay, then I can raise 2 to the power of negative 3 because this negative 3 power is on 2 as well and on this bracket as well. So I can raise 2 to the power of negative 3 and then I get 1 plus x upon 2 to the power of negative 3. So this can be tackled with the expansion formula that we have looked in this class, in which the first term was 1. So on this bracket, you can apply the binomial expansion series formula. 2 to the power of negative 3 times. Okay,
Mm.
so I want you to give me the expansion of 1 plus x upon 2 to the power of negative 3 using the formula.
Okay, so So after multiplying it with, I got 1 upon 8 minus 3 upon 16 plus 3 upon 16 minus 5 upon 32 with all the x squares in it.
Sure. Let's see. So the first term is going to be 1 plus the second term is minus 3 times x upon 2 plus n times n minus 1 over 2 factorial x upon 2 squared plus n times n minus 1 times n minus 2 over 3 factorial x upon 2 the whole thing cube, and it can go on. So if I simplify this, I'm getting 1 minus 3x upon 2. Okay, this is going to be 4 cancelled, minus 3 upon 2 plus 3 upon 2 x square, and the next term is going to be minus 5 upon 32 x cubed. This is what you should get. Sorry,
Yeah,
minus 5 upon 4.
yeah, this is
Minus
what I
5
got.
upon 4. Yeah, okay, great. Then, if now 2 raised to the power of negative 3 is simply 1 upon 8. So, after multiplying each term by 1 upon 8, you're going to get 1 upon 8 minus 3 upon 16x plus 3x squared upon 16 minus 5 upon 32 times x cubed. Okay,
Okay, so yeah,
so
these
this
are the
is the
ones.
expansion of 2 plus x to the power of negative 3. Sorry, are you saying something?
I was just saying this is the ones I got.
Okay, now, what we do? We need to find the value of x for which this expansion is valid. So you cannot jump to the conclusion, okay, that the second term is 1, second term is x, so mod of x should be less than 1. We have used the expansion formula on this bracket, 1 plus x upon 2. So the second term is x by 2 over here. Therefore, the expansion is only valid for mod of x upon 2 less than 1, which means that x upon 2 must be between minus 1 and 1, which means x must be between minus 2 and 2. So for the values of x between minus 2 and 2, this expansion that we have done is going to be valid, right?
Yeah.
Okay. Do you want to copy down anything from this slide, or can I move on?
So you can move on.
Okay. Now we are going to learn to find the coefficient of x square in the expansion of 1 minus 3x over square root 4 minus x. So what is the first step that comes to your mind?
You bring 4 minus x up as 4 minus x to the power of minus half.
Right. So 1 minus 3x times 4 minus x to the power of minus half. Then what do you do?
Then you take 4 common.
Yes. So if I take 4 common, I'm going to get 1 minus x upon 4 to the power of minus half, which would mean 4 to the power of negative half times 1 minus x upon 4 to the power of negative half. 4 to the power of minus half is nothing but 1 upon 2. So I'm going to write 1 upon 2 separately with 1 minus 3x, and I'm going to expand this bracket now. So can you expand this bracket, please?
Yes. So,
We just need to find the coefficient of x square in the multiplication. So we are just going to well, you can just expand it to, you can think like this. So if this is 1 and I need a x square coefficient, so I need a x square term from this bracket and I need a x term. So you can just expand this bracket till x square term. Okay.
okay. So I got an answer, but I'm not sure it's right.
Okay, let's look at that. So 1 upon 2 times 1 minus 3x. Now 1 minus x upon 4 to the power of negative half. If I need to expand this till the x squared term, this is how it is going to be 1 plus n times the second term, which is minus x upon 4, plus n times n minus 1 over 2 factorial minus x upon 4 square, right?
Yes.
So this is going to be 1 upon 8 x, and this is going to be, can you simplify this and give me the value, please?
Um, 3 upon 128.
3 upon 128 x square. Okay. Now we want the term in x, we want the coefficient of x square. So I can get the coefficient of x square when this one is going to be multiplied with this, and when this minus 3x is going to be multiplied with 1 upon 8x. So leaving aside 1 upon 2 for now, I have to multiply 1 with 3 upon 128x square, and I need to multiply minus 3x with 1 upon 8x. So if I multiply now this with half and then this with half, I'm going to get, what is the final answer that you get?
I got minus 93 upon 256.
See, 128 times 2 is 256, that's correct. So 3 upon 256x square minus 3 upon 8x square. So if I divide 3 by 256 and then take away 3 by 8 from it, acha, oh, I need to multiply this by 2 as well. Okay, because this term is also going to be multiplied with this. So now what you are getting? 3 upon 256 minus 3 upon 16. Are you getting negative 45 over 256?
Um, 1 second. Yes, I'm getting that.
Right. Now, basically, the whole idea for us to learn partial fractions first and then binomial series is because that you usually get a question that involves first partial fraction and then a part followed by binomial expansion. So I'm going to do one question with you for this class. The question is, given that f of x is 10x plus 1 over 1 minus 2x times 1 plus x, express f of x in partial fractions and hence obtain the expansion of f of x in ascending powers of x up to and including the term in x cube, and then finally state the range of values of x for which the expansion is going to be valid. All right, so first of all, we need to express this function in partial fractions. Now, you are going to assist me in making partial fractions for these. What can you say about the denominator? What was the first question that we asked ourselves when solving for partial fractions?
Um,
The first question was, is the fraction a proper fraction or an improper fraction?
yeah,
So, what do you think this is?
proper.
Proper, okay. Then, which case does it refer to?
Uh, A and B.
Yes. So, you have two linear factors in the denominator. So, the a upon the first linear factor plus b upon the second linear factor, right?
Yeah.
Okay, so I'm gonna pause it over here and I want to ask you to solve this and get me the values of A and B so that
Okay.
it gives you a practice.
Yes, I'm getting B as 9 and A as 4.
B is 9 and A is 4. I think A value is correct, but B value is wrong.
Okay,
Could
then
you just look at the calculations again?
yeah, yeah, it's minus 3 or 3.
B is minus 3. Are you getting this?
Yeah, I got it.
Okay, great. So A value is 4, so 4 over 1 minus 2x. And B value is minus 3, so minus 3 upon 1 plus x. So partial fraction part is done. Now we need to expand, so and hence obtain the expansion of f of x. So if this is f of x, remember you cannot expand this without making partial fraction. So even if the question does not is not broken down into these expressions, that first they are asking you to express it in partial fraction and then obtain the expansion, if that this statement is not even given and you are given a fraction in this form, combined form, you will have to represent it first into partial fractions, and then you are going to use the partial fractions to expand the brackets.
Okay, I'll just do
So
it.
yeah,
You have to do both of them
so this
separately
is
and
how
then.
you're, yes, please do both of them separately.
Okay. So I've gotten the coefficient.
Okay. So this is what you should get. So if I expand 1 minus 2x to the power of minus 1, 1 plus n b, the second term basically, plus n times n minus 1 over 2 factorial x square plus n times n minus 1 times n minus 2 over 3 factorial x cube. Then negative 3, and then the expansion of 1 plus x to the power of minus 1, which is just going to be, the first term is going to be 1 plus minus 1 times x plus minus 1 times minus 2 over 2 factorial x squared plus minus 1 times minus 2 times minus 3 over 3 factorial x cube. Alright, now I'm going to solve this. So this expansion is going to come out 1 plus 2x plus 4x squared plus 8x cubed, and this is going to be minus 3 times 1 minus x plus x squared minus x cubed. Now all you need to do is simplify the terms out. So this 4 times 1 minus 3 is 1. 8x minus 3, okay, 8x plus 3x is going to be 11x. 16x square minus 3x square is going to be positive 13x square, and 32x cube plus 3x cube is going to be 35x cube. Is this the expansion that you are getting?
Yes, sir.
Okay, great. Then the second part, the third part to the question, state the range of values of x for which the expansion is valid. Now we have two expansions that we have used. The first expansion that we used was where the second term is negative 2x. So negative 2x is same as saying positive 2x mod less than 1. So x is between minus half and less than half. And now for positive x, that is mod of x less than 1, so it is ranging between minus 1 and 1. Now this is just one question, so we need to come up with a common range of values of x. So you can conclude this from a number line. So for one expansion, x is greater than minus 1 and less than 1. For the other, it was from minus half to half. Now, what is a common solution that we can give?
Minus half to half.
Exactly. So, for the range of values of x that is going to be valid is from minus half to half.
Okay, sir.
Make sense?
Yes.
All right. So, that's all for today. Okay.
Okay.
All right.
Thank
Take
you,
care.
sir.
You're welcome.
Allah
Allah
Hafiz.
Hafiz.